Hey everyone, in this video I want to explore Azure virtual machines running Linux and attaching and using storage. Many people maybe come from a Windows background, and the idea of how we interact with storage we add to Linux virtual machines is confusing. Don't know where to begin. So my goal in this video is to just walk through some of the key basics around attaching storage, making available, and then maybe setting some of the permissions. As always, if this is useful, a like, subscribe, comment, and share is appreciated. So what I want to do in this video is I think about, well, we have a virtual machine. So as we know, a virtual machine doesn't run on thin air. There's some host where our virtual machine is actually running. Our virtual machine is provisioned onto a particular host. And then from a storage perspective, at minimum, we have an OS drive. Now, normally this is durable. It runs on Azure storage. Sometimes we use ephemeral, where we use local storage, but most of the time we're going to use a managed disk. So we think about, well, there's Azure storage, and on that Azure storage, we essentially get a managed disk created that has the operating system. So we kind of map to that. Now, additionally, in the host itself, it has a certain amount of local storage. And for nearly all of the virtual machine series, there are some, I think it's like the DV4, that don't have temporary storage. But for pretty much all of them, they also have kind of a temporary drive that also gets mapped to the virtual machine. And we'll see this when I go and show a Linux virtual machine. But then we might want to add other disks. We want data drives. Generally, it's not good practice to put maybe databases, for example, or applications on the OS disk itself. Also, we definitely don't want to put it on the temporary drive because it's not durable. If I deprovision the virtual machine, if something happens, I lose the content of the drive. So we want to think about, well, we'll create additional, I'm going to say managed disks. These are of different types. And so we need to do a few things. So we create the managed disk, then we connect it to the virtual machine. And then if we think about operations, so number one is, okay, I have to kind of connect it. Then we're going to have to partition it. We're going to have to format that disk. And then inside the operating system itself, we'll have to obviously mount it to actually be able to see it. Then we'll have content, various permissionings. When I make this connection to the data disk, I can set the caching. For the operating system, the caching is kind of read-write. That's good for an OS. For a data disk, we might not want that. We want no caching. Maybe it's read caching. It really depends on the workload. So that's kind of the operations that I want to walk through. So let's get started and actually just look at what we have with a Linux virtual machine. So if I jump over to the portal, what we can kind of see here is I've got a very basic virtual machine. And by default, it just has this one kind of OS disk. It's 30 gigabytes. And it's got, as you can see here on the far left-hand side, we have this host caching, and it's using read-write. I'm using standard hard disk drive, the kind of cheapest option, because I'm being cheap. Now, if I actually jump over, this is that actual virtual machine. And what we can see is if we actually look, I can go over here. And if I run the lsblk command, I'm going to look at the block devices. And what I want to see is kind of the name, information about kind of the connectivity, the size, and I want to look at the mount point. So here we can see there's a number of different disks, and what I could do is to try and tidy this up, because obviously there's quite a lot of different things showing here. I can just search for if it includes SD, which are going to be actual disks I care about. So what we can see straight away is there's really two disks. I've got this 16 gigabyte disk, And then I've got this 30 gigabyte disk. I'm down here on the bottom. And I can see that, well, for that first disk, it's mounted as /mnt. The other disk is, well, it's mounted at the root, this kind of slash, and a partition of it is mounted for this boot operation. Now, when I think, so they're just the built-in kind of disks we have available to us. Now, the reason for these weird slashes is when I think about Linux, Linux is all built around kind of this single namespace. It uses this file system hierarchical standard. So inside the actual OS itself, so here we're dealing with Linux, what we start with is this root file system. Everything is a child of that root file system. Now there's things like, well, you'll see a binary folder, you'll see an MNT. You saw that. MNT is used for kind of temporary mountable storage. I'll see opt. I can see virtual file systems around processes. There's all these different folders, but everything is a child off of that root. So if I want to add additional disks, essentially what we do is we add mount points to this namespace. So generally we're going to create a folder that's empty, and then we can attach our disk to that folder. We want the folder to be empty, because if it's not empty, when I mount a disk to it, everything will get removed. So I could think about, well, hey, I'll create a folder called, for example, data1, and then what I'll do is this disk, I'll actually mount it into data1. So anytime I look at this data1 folder, I'm actually looking at the content of that disk. So this would be /data1. That's how we're actually going to work with this in Linux. So the first step would obviously be, well, I have to create a disk. So if we jump back over to the portal, and what we'll do is we'll go, and remember, we can see the disks we have right now. We can just see we've got these two disks, SDA and SDB. Now we can hot add storage. I can hot remove storage. So what I'm going to do is I'm going to create and attach a new disk. Now I can select which LUN. So notice I'm picking LUN 0. I can give it a name. So I'll say Linux Data 1. But saying that's already in use, so I'll call it 01. There we go. I'm going to use the cheapest disk. Actually, I'll use a standard SSD. I'll make it 4. So I'm picking 4 gigabytes in size. And notice I have a host caching option over here on the right. Now, if this was going to be a database, for example, I probably want none. And I'm just going to hit save. So what I'm doing at this point is I'm creating a new managed disk. And now I'm attaching it to that particular Linux virtual machine. Now, so that's been done. If I hit refresh, yep, there it is. So if we go back over to the console and actually clear, there we go, get there eventually. So if we go and look at our devices again, now we see we have 3. So remember, this first one we're looking at, this is the temporary drive. That's that disk that's on the local host. We can see it's the temporary drive because it's using the /mnt, that temporary mount point. And it's 16 gigabytes in size, which is the temporary disk size of that series virtual machine. Then I can see I've got that 30 gig disk, which is the OS disk size I have for this virtual machine. Again, if we jump back, we can see here the size for the OS disk, yep, is 30 gigabytes. And now, well, we have this new disk, SDC, which is 4 gigabytes, which is the size I just created. So that's great. The disk is there, but it's not really usable yet. So the first thing we have to do is actually partition it. Now you will see it is using that LUN 0, this far right hand, that's the LUN. So I'm on LUN 0. So what we've got to do is partition it. Now these are all privileged commands. Now with Linux, basically we use the sudo command. The sudo command lets us basically super user do something. I'm not using su, which just replaces my context as the root user. I just want to run one command at a time. So what we're going to do is I'm using this sudo, so I'm using the part-ed command to actually take that /dev/sdc, so that's the device, that SDC device. Then I'm running basically, hey, I want to partition it using the GPT. We're going to format it with XFS file system, and I want to do the entire disk. So I'm going from 0% to 100%. So that's created the partition. If we go back and look again, now I can actually see I've got this SDC1. So it's actually gone ahead and created the partition. So actually the next thing I actually need to do is do the real format. And to do that, I'm going to use sudo mkfs.xfs. Again, we're using the XFS file system. And I just tell it what I want to do. So I use the SDC1 is the partition that I just created. So now because it's gone through and it's formatted. And then the final thing we do, just to be on the safe side, sometimes Linux won't recognize, hey, there's new partitions. So we can run part probe and it will go and recognize and make sure it's there. So now if we run our command again, the disk is now there, it's available. We've got to mount it somewhere. We actually have to create that folder to do the mount. Now, if we just do an ls on that root, so these are all the root folders under that /. And what you can see is I already went ahead and I created a data1 folder. Now, there's nothing special about that. It's just a folder I created. I literally just ran kind of a sudo make directory /data1. That's all I did to create that folder. There's nothing else special about it. Let's clear the screen. So what we want to do now is actually put something, because if I do ls data1, there's nothing there. There's nothing connected to that folder. So what I want to do is mount that disk. So now we're going to do the sudo mount that partition we created, and I want to mount it into data1. Now if I do this ls data1, it's still empty, but now it's actually connected to the disk. If we run that other command to actually look, now we can see that partition we created is actually now mounted at data1. I could also look, for example, at the mount command. Once again, we're going to get a whole bunch of stuff. So if I just grep, i.e. search for SD, I can see all the various mounts. And here we can see that, yes, at the bottom line, that dev SDC1 is mounted on data1 of XFS file system type. There's also utilities like disk free. So if I do df-th, I can see all my devices. And once again at the bottom, now I can see, yep, I've got this 4 GB mounted drive under /data1. So what we have at this point achieved is, if we look at our picture, we created the disk, we partitioned it, we formatted it, and then we've mounted it. Now this mount is temporary. It's not going to survive if we actually reboot the Linux operating system. If we want it to survive and automatically mount at startup, we actually have to modify the fs tab file. So if we go back over to our Linux VM, what we can actually see is if we type out our fs tab, these are all the disks that it's going to automatically mount. And we would just edit this. Now, to actually edit this, we need the actual UUID of the disk. to actually be able to add that into the file. So what we can actually do to get the UUID of our new disk is if I sudo and run my block ID command, blkid, it shows me all of the disks, and there we can see that dev SDC1 and that UUID. So that's the value I would need to actually keep. So I would take that and copy it. And then I would just have to edit that fstab file. So I could go sudo, and I'll use nano because it's easy to use, etc fstab. And there's our file. And essentially at the end of it, I would just add in my UUID equals that value. And then, hey, I want to mount it as data1. Actually, let's just tab that. Data1. It's XFS, defaults, no fail, 2. And I would just save that. So I would do Control O and then Control X. And that will auto mount at the next startup. So at this point, we've added our storage and it's now usable. That's adding the disk. So it's really no different from Windows. With Windows, we would have to attach the disk, we would create partitions, we would format them. Really doing the same thing. Even in Windows, we don't have to mount as a drive letter, we can mount as folders, we can do symbolic links. So in Linux, hey, we just mount it as some folder. Then the next thing we're actually going to want to do is, well, I probably want to put data in here. So within this data1, I might want to create additional directories, dir1, dir2, and then some data. Super important point, Linux is case sensitive. Windows is not case sensitive, it does not care. Uppercase dir1, lowercase dir1 is not the same folder. A lot of the commands, they're case sensitive. So you have to be super careful with case in Linux. Windows doesn't care, Linux absolutely cares. So the next thing we want to think about is, well, permissionings. And I can really think about, in Linux, you have a user. The user has a primary group, and then there's everyone else. So I can think about, well, there's the user who kind of owns the data. There's the group that owns the data. And then there's others. So there's these three kind of categories that are available. And the permissions we have to play with are basically at each of these levels, we have read, write, and execute. At every level, we can set that. Now there's kind of an absolute method of doing this and a symbolic method of doing it. The absolute is where we use numbers. And the way the numbers work is it's binary. So there's 3 possible bits here: read, write, execute. That's really all there is. And so when I use the absolute method, what I'm actually going to do is, well, which of these am I using? And it is in that order: read, write, execute. So I can have 1 or 0 if I have the permissions. So in binary, this would be a value of 1. That would be a value of 2. That would be a value of 4. So if I just wanted to give read permission, it would be 4. If I wanted to give read, write, and execute, 4 plus 2 plus 1 is 7. That would be everything. If I wanted to just give read and execute, 4 plus 1 is 5. So that's how the permissions actually work. So if I was to say, well, user gets 7, group gets 5, and other gets 4, what I'm really saying there are the effective permissions are read, write, execute, read, dash, execute. The dash means doesn't have that one. And this one is just read, dash, dash. So that's how we do the permissionings in Linux. So as a file, I have an owner. So there's a user owner and a group owner, and then there's permissions for the user, permissions for the group and the people who have access part of that group, and then others. So that's how the permissionings actually works in Linux. Again, there is a symbolic version as well, where I can actually just say, hey, owner equals RWX, group plus. I could add or remove permissions. But we'll stick with kind of that absolute. That's the one you're going to see most common when you actually work with Linux. So remember that that's really all it is. There's 3 permissions: read, write, execute. So for be it a file or a folder, I can set those permissions, read, write, execute, at the owning user, the owning group, and other levels. So that's really all we're doing. There are more advanced ACLs you can do. If you actually go and look, and we'll look at this, if you see a plus at the end, it means there were other ACLs applied. So someone's using that more advanced set of ACLing capability. But let's kind of see this in action. So we jump back over to the portal again. So what we'll actually do at this point is let's actually go to our data one. / till I'm a Windows person. If I do, actually just to clear this, if I do a pwd for present working directory, we can see I'm in data one. So before I do anything else, we wouldn't normally create files in the root of a folder. So what we'll do is we'll actually create a new folder. We'll make a directory. This is in data one. We'll just call it John Data. But what I want to do is if I quickly just look at this, right now I can see, well, it's root. So root owner, user, and root owner group. Notice also the permissionings. I can see that first character is a D because it's a directory. And then what it's done is it's read, write, execute for the permission. So that would be 7, read, write, execute for the owner, user. Then it's just read and execute, but not write for the group. And then read, execute for other, everyone else. So we can see it's done those default permissions. What I'm actually going to do is I'm going to change the owner to John for John Data. Okay, so now I am the owner of that. So if we go into that folder, right now it's empty. So let's actually create something. So if I use vim hello world, to insert, I have to tell it, hey, I'm actually using bash, and then I want to hello world, and then escape to exit the insert mode, colon, WQ, write and quit. So let's save that data. If I do an ls/l, well, I can see here, actually this is clear, I'll show this at the bottom. There we go, it's easier to see. So now we see the first character is a dash because it's not a directory. And then I can see the owner, i.e. me, I have read, write, but not execute. The group has read, write, but not execute. Everyone else has just read. Now there's an ACL package you can do. You can do an apt install for ACL. And what that gives me is if I do get f ACL, ACL, on that, it shows me kind of those same details, just a little bit easier to read. The owner, the group, the user, group other. There's no plus at the end, so there's no additional ACLs that are present. So what can I do with this? So I'm the owner, I am John. So if at this point I was to do, let's just kind of run this file. So if I do ./hello world, it fails. I'm the owner, but the permissions don't allow that because there is no execute even for the user owner. So what I'm going to do is I'm going to do change mod 700. So what is that doing? 7 is everything, remember. If we think, so 7 7 in our picture is 4 plus 2 plus 1. So it's read, write, and execute. So I'm giving myself read, write, execute as the owner of the file. And then what I'll do for the others is 0, 0. 0 for group, 0 for everyone else, other. And I'm going to set that on hello world. So now if I look at the file, yep, I now have read, write, execute. We can see that at the start. Everyone else has absolutely nothing. So now I should be able to execute that command. It's saying command not found. Oh, I think I missed out echo. So let's edit that again. Terrible demo. But I think that should be echo. And there we see hello world. There we go. So at the bottom there, we can see it ran and it output. So I can now execute. So now we think about, okay, well, I probably want to share things with other people. So I could, for example, change that group. So what I'm now going to do is I'm actually going to use the change group command, and I'm going to set the group owner to this group called JL for that file. So now if I do an ls/l, I can see now the group owner has changed to JL instead of John. And what I've done is I've created a user called Clark. So if I look at the groups for Clark, I can see, well, Clark's primary group is Clark, which is the regular for Linux, but also has the JL group. Now, right now, I'm going to try and run the command as Clark. So I'm going to run sudo as -user Clark. And I'm going to try and look at that file. So data1, John data, hello world. And I typed it wrong. I did data instead of data1. Permission denied. Because right now there's no group permissions at all on that file. So what we'll do is we'll change it, and what we'll give is 750 for that file. So we're saying 750. So 5 is the group. Remember, what is 5? We go back to our picture of permissions. 5 is 4 plus 1 gives you 5. So I'm giving it read and execute permission. So now people who have that group should be able to read and execute the file. So we jump back over again. I've made that change. We could, again, look in a more friendly way at the various permissions. Yes, we can do ls/l, and I can see there's the rx now, but we can also use the prettier, go back through the history. Now I can see, yes, the group has that kind of rx set of permissions. So now Clark should be able to not only type out the content, which Clark can, but Clark should actually be able to just run it, which Clark can. So we can see there's those permissions working. Now I could change the permission to 740. Remember, 4 means just read, not execute. So now if Clark tries to execute the file, permission denied. Can't do that because, well, doesn't have the execute permission. So you can really see all those different things flowing together. It's showing me using those. Now, one other thing, when I think about inheriting permissions, if I change attributes of a folder, by default, files are not going to inherit them. For example, if I'm in my John data and I make a directory, and I'm going to call it JL data. And if I look, well, I can see the JL data is John. So John is the owner and John group is the owner as well. Now, if I change the permissions on this, so I'm going to change the group to JL for JL data. And now I can see, hey look, JL for this folder is now the owner. Great. If I go into JL data, and look, there's nothing there. Let's clear for a second. If I just create a file, just use touch, test file, and do an ls/l, well, it's not inheriting that group ownership. It's inheriting the user that creates it. It's back to John. If you want it to inherit the group permission of the folder, I can set that at the folder level. So if I go up a level and look again, what I can actually do is I can use a change mod, and we're using something here called the setGid bit, the group ID bit. So I can do change mod, and I'm saying, now I'm using the symbolic, so I'm saying the group owner add that set bit for JL data. I'm looking here. Notice if we look at the output now, and it's actually going to be easier to see if I use the other command. You can see it here. You can see there's an S. So it's added in that S here for that kind of that set bit, the set group ID. If we go and look at R all the way back, we'll just run that command. I'll type in JL data. We can see the flags. So it's actually got that flag -S dash. So owner, group, other, the S is set in the group area. So what it should now do is inherit that group owner for any files I create. So if I go into JL data again, remember right now it's just John. If I touch another file, so do test file 2, we'll now notice the group owner is JL. So it's inheriting it from the folder to actually enable that. And that's really the sum of most of the kind of activities you'll actually perform. So we really went kind of the full gambit of, well, yeah, created a disk, we partitioned it, we formatted it, we mounted it into the OS, we created folders, we set permissions, we set how we could inherit for the group, which is going to be super useful. The other thing you might want to do is detach a disk. Remember, I can attach and detach. Before I detach it at an Azure VM level, make sure we unmount, mount the disk. So if we jump over just to kind of finish this off, in fact, before I unmount it, just to kind of demonstrate if there were multiple data disks, if we go back here, I'll actually add another data disk, Linux data 02, and we'll do the same again. And hit, now remember the SCSI here, LUN here is 1, but I'm going to set it to 10, actually set it to 9, just so you can see that in action. So we go to here, set that it's created. If we do our, so far back in our history now, but go back to the ls blk, just to look at those. There we go. So now we can see there's the other disk is there. And we can see the LUN is 9, because that's what we selected. Notice it's not mounted anywhere yet. But if I was to just go home, in this case, I could actually now unmount the disk. So if I could do sudo u, it's not it's umount, and then where you mounted it. So data 1. I've now unmounted that disk. So if we go and look at our list of disks again, the partition's still there, but there's no mount anymore. And so now I could actually go and remove them from the virtual machine. So that's updating the VM. And we'll be impatient and see if they've gone. And they've gone. So really that was it. Now, because obviously I unmounted that disk, I'd need to go back into the file we edited, that FS tab, so it doesn't try and mount it at next startup. But that's really the life cycle. There's nothing that special about it. It's just if I'm a Windows person, it's a little bit different. But really the actions we're taking are the same. It's just different commands to do that. In NTFS, we have different levels of permissions. Again, I've shown the super simple ones. There are richer ACLs available. You can, again, I showed you kind of the get ACL. There's also a set. So I could set more advanced ACLing if I need to. But that's kind of the basics of just, hey, attaching some storage, making it available, and maybe creating some folders and making it available to other people. And that's it. I hope this was useful. And until the next video, take care.